Betelgeuse, or Scarab Jew, is a red supergiant star. Imagine placing it where the Sun is. It would expand to the orbit of Jupiter. This massive and remarkably unstable star will eventually explode, producing one of the most powerful bursts of energy in the universe, generating more energy than a billion suns. Betelgeuse, one of the most prominent stars visible in the night sky, adds a dramatic element to the cosmic scene. What makes Betelgeuse even more remarkable is its distinct orange hue, which immediately catches the eye. Unlike many stars that maintain consistent brightness, Betelgeuse is classified as a variable star, meaning its brightness changes over time, adding mystery and allure. At times, Betelgeuse can shine so brightly that it rivals or even surpasses the most brilliant stars in the night sky, making it an object of fascination for both amateur stargazers and professional astronomers. Over the years, speculation has grown in the scientific community about whether Betelgeuse could be nearing a cataclysmic event known as a supernova, and what effects this might have on its surroundings, including Earth. While the thought of a nearby star explosion might seem alarming, it's an event that astronomers eagerly anticipate as it could provide valuable insights into the life cycle of stars. To explore Betelgeuse's current state and future prospects, we invite you to follow our channel. If you're fascinated by the universe and want to stay updated on the latest space news, subscribing to our channel, liking the video, and turning on notifications is the best way to stay connected. Betelgeuse's sheer size is astounding. If this star were to replace the Sun in our solar system, its massive reach would extend far beyond the orbit of Mars, engulfing the inner planets, including Earth. Not only would it dominate the space within Mars' orbit, but its outer layers would likely reach into the asteroid belt, a vast region filled with rocky debris and smaller celestial bodies. This portrayal of Betelgeuse's size is both awe-inspiring and somewhat intimidating, highlighting just how small Earth is within the vastness of the universe. Despite its enormous size, there's no need for alarm. Betelgeuse is located at a safe distance of about 642 light-years from our planet. Though this might seem like an immense distance, in cosmic terms, it places Betelgeuse relatively close to us, especially considering that it is the closest star to the Sun expected to end its life in a supernova. Because of this proximity, Betelgeuse has become a focal point of astronomical observation, with scientists eager to witness such an event. As the renowned astrophysicist Neil deGrasse Tyson explains, a star's brightness can fluctuate due to several factors, such as size, temperature, and distance. For instance, stars like Rigel and Aldebaran, while both bright, experience variations in their luminosity. Aldebaran at its peak may be as brilliant as Rigel, but during its dim phases, it could fade into relative obscurity compared to dimmer stars. This variation in stellar brightness provides valuable insights into the star's life cycles and ultimate fates. In recent years, these changes have captivated both stargazers and space enthusiasts alike. The name Betelgeuse itself has a rich linguistic history, tracing its origins back to Arabic. Linguists and scholars have debated the precise structure and meaning of the name, but its current usage is widely accepted as the most fitting for describing this famous star. Betelgeuse belongs to the class of red supergiants, one of the largest and most massive types of stars in the universe. It resides in the constellation Orion, which is easily recognizable in the night sky due to its distinct arrangement of stars. Positioned about 642 light-years from Earth, Betelgeuse is far enough away to pose no immediate threat to our planet but close enough to be a prime target for cosmic study. The advancement of high-tech astronomical tools, such as the Hipparcos astrometric satellite, Betelgeuse is truly a giant among stars. Although it's enormous, it's cooler than the Sun, with a surface temperature of around 3,600 K, compared to the Sun's 5,778 K. Despite being cooler, Betelgeuse's luminosity is extraordinary, shining with a brightness over 100,000 times greater than the Sun's. Though it's located 548 light-years away, Betelgeuse is considered a relatively young star at around 10 million years old. By comparison, our Sun is a middle-aged star at about 4.6 billion years old. However, despite its youth, Betelgeuse is nearing the end of its life. As a red supergiant, it has already exhausted much of its nuclear fuel, and its final stage will be to explode in a supernova. When this happens, it will mark one of the most spectacular events in the cosmos. It will deliver an inconceivable measure of energy, and the impacts could be obliterating for anything inside a couple of hundred light-years of the blast. A cosmic explosion of this extent would produce as much light as a whole system, surpassing everything around it. On the off chance that a star like Alpha Centauri, one of our nearest heavenly neighbors, were to go through such an event, it would be difficult to miss. In any event, it would appear as bright as the moon in our sky. The radiation produced by the blast would have serious ramifications for Earth. Luckily, no cosmic explosion has been seen in our system since 1604, despite the fact that space experts noticed a cosmic explosion in the Large Magellanic Cloud in 1987. This event happened 169,000 light-years from Earth, yet it had an obvious impact, showing the broad effects of these tremendous impacts. When a star goes through an immense blast, it abandons leftovers, which are the remaining material from the impact. One outstanding model is the object known as G292.0 plus 1.8, which is a remnant of a grandiose blast that happened some time ago. These leftovers are uncommon and frequently contain high concentrations of oxygen and different elements. The Large Magellanic Cloud, where the 1987 cosmic blast happened, is far enough from Earth to pose no risk, except that it serves as a reminder of the powerful forces at work in the universe. If a vast blast were to happen closer to us, inside 100 light-years, it could have significant outcomes. Stars like Alpha Centauri, which are within this reach, could present a possibility to impact. However, Betelgeuse, while somewhat close, is found beyond this peril zone, implying that we are not in danger from its potential grandiose blast. By the way, researchers are intently monitoring Betelgeuse, as its eccentric nature makes it a star of great interest. The inquiry on everybody's mind is whether Betelgeuse has already detonated. As the nearest red supergiant to Earth, Betelgeuse is the star most likely to experience a grandiose blast soon. In late 2019, the star went through a significant and unforeseen darkening, which prompted a lot of theory. Some believe that this darkening was an indication that Betelgeuse was nearly detonating. In that capacity, behavior can sometimes precede a grandiose blast. The dramatic decline in brilliance caused worry among researchers and the public alike. However, despite the initial alarm, Betelgeuse has since recovered much of its brightness, and it appears that the star is currently in a more stable state. For the present, it shows up that Betelgeuse's last blast isn't impending. But it remains an object of close observation for space experts. Betelgeuse, with its distinctive red tint, is a prominent sight in the night sky, particularly during the winter months. Its position in the constellation Orion makes it easily recognizable to stargazers. Thanks to observations made by NASA's Hubble Space Telescope and other ground-based observatories, astronomers have gathered important information on Betelgeuse's behavior. In 2019, Betelgeuse experienced a massive surface mass ejection during which a portion of the star's outer layers was blown away. This event caused the darkening seen from Earth. Surface mass ejections are comparable to coronal mass ejections, CMEs, that happen on the Sun, where part of the Sun's outer atmosphere is ejected into space. However, the mass ejection from Betelgeuse was on a much larger scale, ejecting 400 billion times more material than a typical CME from the Sun. This gigantic haze of gas briefly obscured some of Betelgeuse's light, prompting the dramatic darkening visible from Earth. Despite earlier estimates putting Betelgeuse at a greater distance, later measurements suggest that the star could be as close as 724 light-years from Earth. Estimating the distances of red supergiant stars like Betelgeuse is challenging for astronomers, as these stars are often shrouded in clouds of gas and dust that obscure precise measurements. Even with the uncertainty surrounding its exact distance, Betelgeuse remains one of the brightest stars in the night sky. Its immense energy output, which is more than 100,000 times greater than the Sun's, is accelerating the process of fuel exhaustion within the star, bringing it closer to its inevitable end. As Betelgeuse continues to evolve, astronomers are watching closely, eager to learn more about the life cycle of stars. Betelgeuse, also known as Alpha Orionis, has captured humanity's imagination for hundreds of years. Its prominent position in the constellation Orion has made it a crucial reference point for navigators and astronomers alike. The star's name derives from the Arabic expression Ibt al-Jawza, meaning the giant's shoulder, highlighting its historical significance in various cultures. Despite its impressive size and brightness, Betelgeuse exhibits fascinating characteristics that make it a unique object of study. One such feature is its pulsating nature. Scientists have identified that Betelgeuse undergoes periodic changes in brightness driven by its outer layers expanding and contracting. This behavior is often attributed to complex interactions within the star's atmosphere, influenced by convection currents and pulsational instabilities. Such pulsations can last anywhere from a few weeks to several months, further contributing to the star's variability. Interestingly, Betelgeuse may not be a single star, it could be part of a binary system. Some evidence suggests it could have a companion star that may influence its evolution over time. The gravitational interaction between these stars could play a role in the shedding of material from Betelgeuse's outer layers, contributing to the changes in brightness observed by astronomers. This potential companion adds another layer of interest to the study of this red supergiant. The colossal energy output of Betelgeuse also has implications for its surrounding environment. The intense radiation and stellar winds produced by the star can significantly affect nearby cosmic structures, such as the Orion Nebula. This region is a stellar nursery where new stars are born, and the impact of a nearby massive star like Betelgeuse can trigger the formation of new stars or alter the trajectories of existing ones. Astronomers continue to study these interactions to better understand how massive stars shape their environments. Another captivating aspect of Betelgeuse is its stellar life cycle. As a red supergiant, Betelgeuse has evolved from a main sequence star during which it fused hydrogen into helium over a long period. As the hydrogen in its core was depleted, it transitioned to fusing helium into heavier elements like carbon and oxygen. This cycle continues until it eventually reaches the iron stage, where fusion ceases, leading to its catastrophic collapse and subsequent cosmic explosion. Understanding this evolutionary pathway has helped researchers piece together the life cycle of massive stars, which ultimately enrich the interstellar medium with heavy elements upon their demise. Moreover, studying Betelgeuse provides insights into the phenomenon of gamma-ray bursts, GRBs, possibly the most energetic events in the universe. While Betelgeuse is not expected to produce a GRB, examining its characteristics and potential supernova could offer clues about the conditions under which such explosive events occur. GRBs are believed to result from the collapse of massive stars and are among the brightest explosions observed, with the potential to outshine entire galaxies for brief periods. Beyond its scientific significance, Betelgeuse has permeated popular culture. It has inspired numerous references in literature, film, and music. The star's unique name even led to the title of the famous Tim Burton film Beetlejuice, showcasing how celestial objects can capture the public's imagination. These cultural connections highlight the star's appeal beyond the realm of science, drawing interest from a broader audience.